Hello and welcome to this repair tutorial, and today we're going to look at an Aram, and the model number is DiVA and that's an A75. In terms of general specifications, RMS power output is 50 watts per channel, that's into 2 times 8 ohm speakers, and with a frequency response of 20 Hz to 20 kHz, and then total harmonic distortion comes in at 0.1%. And then if you're connecting a turntable with a moving magnet type cartridge, your input sensitivity then is 1.9 millivolts. And then for all of your other line inputs, maximum would be 260 millivolts. It also has a preamplifier output, which is 540 millivolts. And then dimensions is 430 wide by 85 millimeters high and a depth of 330 millimeters. And the weight of the amplifier is 5.6 kilograms. When purchased new, it also comes with a remote control, which of course can be used to select the appropriate input and also control the volume. Now, with the DiVA range, and just to sort of explain what that actually means, it just stands for digitally integrated video and audio. And Aram made a complete series of amplifiers and also other devices which carried the DiVA brand name. There's also an A65 which comes in at 40 watts per channel, so slightly less than the A75. So the customer contacted me via the YouTube channel, and they'd seen a previous repair video and advised that the amplifier was not powering on. So when it arrived, first thing of course to check is to verify if the input mains power protection fuse is intact or it's failed. So here what you can see is that the fuse has gone open circuit, and then this would indicate that there was quite a high current consumption. Now the value of the fuse is a time delay, and it's a 1.25 amp fuse. And then normally with the Aram amplifiers, what you'll find on the PCB is like a plastic clip, and they always provide a spare fuse, but the customer hadn't sort of taken that fuse or used it. The other thing to bear in mind, you can see it from this photograph, there's also another fuse holder and there's no fuse. You know, whatever you do, don't put a fuse into there, because the toroidal transformer is designed for either a 230 volts power input or 120 volts, and you just put in there the appropriate fuse. Of course, for the higher current rated fuse, that would be in the lower voltage or the 1115 volt voltage input tapping. So normally when these amplifiers fail in terms of the fuse, there is an historical problem which develops over time, and that problem is related to the solder joints on the main audio output transistors. So the first thing that you need to verify is there a short circuit on any of the output transistors, and that's very easy to do, because when you look from the back of the amplifier, you just have fixing screws which screw through to an aluminium plate, and those aluminium plates are used to clamp the power output transistors directly to the heat sinks. So what I'm showing you here is the amplifier which has been removed from the metal chassis, and I'll mention how you do that in a moment. And I've also removed the rear fixing screws, so the plates are not in place, and what you can see, a little bit like tower blocks, you can see 2 sets of heat sinks either side, and the Sanken power transistors are mounted onto there. Now, in terms of removing it from a chassis, it's easy to do. Sometimes I've even seen sort of repair videos where people will remove the complete back plate. The problem with that is you're kind of doing extra work which you really don't need to do. So when you spin the amplifier around, there's just a series of fixing screws which holds the back plate onto the metal chassis, and then you have a fixing bolt through the toroidal transformer, and then there's a series of screws which also go through the main PCB, effectively grounding it to the metal casing. And then you've also, if you look just to the right, there's a ground lead which is flying in the air, and there's a bolt and a locking washer and nut. And then when you move to the front of the amplifier, it's a straightforward job. You've probably got about 8 screws in total just to remove the plastic bezel, just pull off the different knobs, and then you should be able to just extract the complete amplifier assembly with a metal bezel with all the potentiometers fixed onto it, and then just put the chassis to one side. So on this photograph, what I've done is I've just zoomed in on one set of the Sanken output transistors. Now these are very, very common on Cambridge audio amplifiers as well as the Aram. What they are Darlington pairs. So just to sort of clarify what we mean, with the Darlington transistor you have 2 sets of transistors within the same package, and the objective from the design of such a device is that it can handle a lot more current within the same package. And what you see here, there is an NPM, which is the NY, and there is also a PY, which is the PMP version for the push-pull output pair for each one. Now on the Cambridge amplifiers, and if you sort of talk say about the A5 or A500, it was very common that these transistors went short circuit. You don't tend to find it here. What you'll normally associate it with, and if we look at this example here, there's always dry solder joints on the output transistor, so that's the reason why the fuses fail, but thankfully it does not destroy the output transistors when it happens. Now with these amplifiers there will always be dry solder joints, so what I do is I always work systematically. I know that I need to go and resolder the output transistors, but I simply start here from left to right, so I know that there will always be bad solder joints on the input RCA socket, so I just work my way around. So I'll resolder all of those, then I arrive at the first set of Sanken outputs. I will reflow all of the connections, and what you'll find is they're just broken away from the circuit board. Then the next set, and I will also resolder the Euro style mains connector socket, always dry joints on there. And then what you'll find is there's going to be dry joints on the headphone socket, and then also the user control potentiometers. Now sometimes you may overlook these, but you have to resolder them. You'll find that there's hairline cracks around the bass, treble and balance controls. Resolder all of those, and then also on this amplifier there are two 5-volt regulators, and they run quite hot, and you'll tend to find there's some discoloration around the pins due to heat. So again, if you need to, just desolder them and then reflow with fresh solder. So once you've done all of that, and I'm just showing you here, this is the tone control circuit of the amplifier. So these are the potentiometers, which we mentioned a moment ago, which always develop dry joints. And you also need to solder the pins of the switches, so you've got to left and right here. Again, if you wish, and you can do this now or you can do it later on if you're doing the repair, you could spray into there deoxit, and then you could clean the user controls and also the switches. So rotate the potentiometers backwards and forwards multiple times. That will clean the carbon track. And then in the case of the switches, you can see that there's a small little access hole. Spray directly in there, leave it maybe a couple of minutes, and then just operate those switches multiple times. And then when you come to your test phase, it's sort of one of the jobs that you don't have to do because you won't find that there's any noise or intermittent contact. Do the same also for the volume control. So if we sort of just move on then to the next part, what you'll find that there is a single relay, and that is that black device there, and I'll put the part number and description below for the video. Now I hold these relays in stock, and because this amplifier would have been used extensively, I just replaced the relay. The reason being is that the contacts become worn and you get internal oxidization. And what I don't want to be doing is testing the amplifier, or maybe the amplifier goes back to the customer. In a few months' time they then develop maybe an intermittent contact inside of there, or maybe some level of distortion. So I simply just swapped that relay out. Now during examination of the amplifier, what became apparent was that at some point in time it had been in maybe a damp environment. I wouldn't say hugely, but maybe it had been stored in an attic. And the thing which brought concern was that these diodes that you see in here on the input RCA connectors are 1N4148 signal diodes. Now when I looked at some of them, what you could see is it's almost like a green mould which had formed around the component leads. Now it wasn't causing any issue with the amplifier, but as a matter of course it's wise to swap them out if you see that, because it will only lead to further issues. Now there's a total of 32 diodes here, so it's going to take you a reasonable amount of time, but the board is marked for the anode and cathode. So what I've done is I've just installed brand new diodes. So here what you can see is with all of the diodes removed, and the switch on the left hand side is used to select the phono inputs. Now this is where you select a moving magnet type cartridge, but if you disengage the switch then it will go back to a standard line input. So once all of those diodes were then replaced, I could then put it into a test phase and then to verify that the operation of the amplifier was correct. But we actually discovered another fault, and I'll mention that in a moment. What I do want to bring to your attention is this device here. So this is the microcontroller. Now Aram have gone through a period of time, and what I would say now is that if you contact Aram, you will receive excellent support. And for anyone who's restoring amplifiers or maybe repairing amplifiers, often the microcontroller may well fail for whatever reason, and if you need to replace it just by contacting Aram, normally they can provide a replacement micro. Of course you need to verify, because here on this amplifier, I won't get into too much detail, but on previous repair descriptions for similar amps, the voltage supply regulator is relying on a Zener diode, and sometimes what you can find is the Zener diode just drifts high above the operational safe voltage for the micro and then can destroy the micro. So if you do get a microprocessor failure, before you install your brand new one from Aram, just verify that voltage supply is correct. As I said, I have done repair descriptions before. I just switch those diodes out and make sure that the voltage regulation is correct, and then replace the micro. and you'll be restoring the amplifier back to normal operation. So i.e. you'll be able to do all of your input selection. It just doesn't remain on one single LED in a static mode, and of course it will then energize the speaker protection relay and operate as it should. Now, I mentioned a moment ago that there was a number of other faults during the test phase. Well, the first one which became apparent was the input selection encoder, and that's what I'm showing you here. Now, again, this is always age related, and you can apply this to any amplifier which you're looking to work on that uses an encoder or some form of switch which is acting as an encoder. And all I simply mean by that is that the microcontroller will read pulses, and those pulses will then be interpreted. In turn, it will then switch the analog input switching device. In this amplifier, it uses multiplexers. In other amplifiers, you'll see a dedicated analog input switching component. And what you find is inside the encoder, two things happen. The first one is that the switching contacts become oxidized, so that's normal because it's metal. And what you'll also find is that the original lubricating grease, because it's metal moving on metal, starts to solidify and almost act like an insulator. And the problem there is that the microprocessor can sometimes read that as an intermittent switch contact coming in, so it thinks that the operator has changed the input selection. Now, it's a bit weird when you first see it. If you operate from the remote, of course, it's not moving the encoder, but you may well see that the input selection just changes randomly, and you think, well, what's kind of going on there? You know, don't go down the avenue of believing that maybe it's a microcontroller fault. It isn't. It's simply that the encoder needs to be cleaned. So, dead straightforward, you just remove it via the torque screws that you see here, and then on this photograph I'm just showing you the encoder which has been taken apart, and you can see the rotary mechanism in the encoder, and here it's very dirty. So what I do is I just take some kitchen towel, and then I'll use Servicol Super 10 switch or contact cleaner, and I will spray it onto there, and I'll remove all of the legacy grease. And then the next thing that I will then use is a fiberglass pencil, just very lightly, just to run over the contacts, and you'll bring them back, you know, to the same condition that when the encoder was originally manufactured. And then I just put a small amount of deoxit grease on there, and then that just provides that longevity and straightforward enough to just reassemble the encoder and then put it back in. And again, I've mentioned this on other repair tutorials. Maybe if you have a safe, I don't have one, but you should have that indexing mechanism, you know, as if you were like click, click, click. That's what you hear from the encoder. You get a very, very positive feedback to the user by the selection knob, and it just rotates and indexes round very, very cleanly and sharply. And that will guarantee that for many, many years, you know, that encoder is going to work perfectly, and you're never going to have any issues with random switching of inputs. Now, the other concern which became apparent was that when the amplifier was put on test, for the majority of the input signals, with no signal connected from the rear, you couldn't hear any noise. But then you had the other issue that if you selected, for example, the DVD input, or maybe the push button on the front to select the tape, what you then started to hear was a crackling sound. And that crackling sound was on the right channel. And you knew that it was originating from an earlier stage of the amplifier. It wasn't in the pre-amplifier stage or the power amplifier stage, because if I rotated the volume control up to maximum, and I've got some headphones connected, I'm not doing this via the speakers, you could hear this crackling sound. It's really, really loud. So that tells you that you had an issue which was in the early stage of the amplifier. So what I'm showing you here are the multiplexers. So on this amplifier you don't have a dedicated custom IC like a Toshiba device. What you have is multiple multiplexers, and there are multiplexers which are being used for the left and then for the right hand channel. So if we jump to a schematic, what you can see here, this is from the service manual, and then what I'm indicating is where I was doing the measurements. So all of the other inputs were fine, but if I selected DVD, and it also says /AV, and then the tape input, you had this crackling noise. So I would just simply use an audio signal tracer. So what I was doing, I was just checking it on the output pin of the multiplexer, and then if I selected the other inputs, no noise. As soon as I selected the relevant inputs, AV, DVD, tape, you had this crackling sound. So that confirmed that that multiplexer was the issue. So straightforward enough. You know, one thing about these amplifiers, what I will say, the circuit board quality is excellent. On some amplifiers, you know, the copper foil is very, very thin. And if you try and even desolder a component, you can find that maybe the track lifts off the board and you have to do some other work. With the Aram, no concern. You know, good solid copper track, and then you can desolder the multi-pin IC with no concerns and then install the new device. Now once that was done, then you were rewarded of course with no crackling sound. Now this fault may well have been present before the failure of the fuse. It may well be that the owner of the amplifier never used any of those input channels or even the tape and was even aware that the fault was there, or it may have developed later on. But you kind of find this sometimes, you know, it's like anything, you have to repair the power up issue, which was the fuse and the dry joints, before, you know, you would realise that this was a fault. But yeah, interesting. And then here what I'm showing you is a top view, and that small hole in between those two copper inductors, that's one of the fixing screws where the amplifier mounts then to the chassis. And then on the left and then the right hand side, what you'll see is that there are two preset potentiometers there. Now those two presets are used to set the bias for each of the channels. Now what's a little bit strange, and what you can see here, is I've just put a series of arrows on many amplifiers, and I'll use the example of Rotel. When you are connecting your multimeter to measure the bias current, normally you're measuring it across the emitter resistors, but in the case of the Sanken SAP15 devices, the emitter resistors are actually inside of the Darlington package. They put small pins so you can connect your multimeter, but not for this amplifier. What they've done is they've just got a small circle around, and then what you'll see is it will say bias positive and then bias negative. And on the left channel it's quite easy to connect, but on the right hand channel it's quite close to some other components. So what I would say is use hook clips. Don't sit there trying to balance your multimeter leads and then glancing at your multimeter and then making an adjustment, because it's very easy, you know, for your probe leads then to slip. So just use your hook clips and then power up the amplifier. And then what you do is you leave the amplifier running for about 15 to 20 minutes, and then what you can see here, and this was sort of interesting, is that the bias on the amplifier was running high. Now this is the right hand channel, and the left hand channel was slightly high, but not as much as this. So you can see here it's up at, you know, nearly 55, 56 millivolts. So yeah, running relatively warm, but again not a fault. This just means that over time the amplifier circuitry has drifted and you just need to realign it. So no inputs would be connected to the amplifier. You would not have any speakers connected. Your volume control will be set to minimum, and then your treble and bass controls will be then set to midpoint. And then here, with an extract from the service manual, you can see the Darlington transistors. So these are the two packages in one device, and you will make the adjustment via the test points as we mentioned a moment ago until your multimeter is reading 37 millivolts. So you're going to do that for the left channel, and then you will then do it for the right channel. And then if we look here, what you can see is this is after adjustment, and it's showing you the left channel. So we're approximately at 37 millivolts. Don't be concerned here because it's saying minus. It just means my probe leads are switched around the opposite way where the hook clips are connected to the component. So once the bias was set and the amplifier then was left on test, here when you look from the top of the amplifier, all the new diodes are installed. We have the new fuse fitted, and then the amplifier put probably under about a 4 to 5 hour test. So we just run it continuously, and also as well the amplifier is power cycled, and there was no concern at all with the operation. Overall, I do enjoy working on the Aram series. I like the metal construction. I never feel that there's a compromise on quality, and the components used with it and the amplifier are always of good quality. And the board layout, again, nice design. And the service manual as well, because it's available and you can download it. I would imagine if you email Aram with the excellent customer support they provide, they would probably email you the service manual. It's very detailed. I've mentioned previously in other repair tutorials that sometimes you can get service manuals and it's just really just a schematic and how to set the bias. That really brings us to the end of this repair tutorial. So as always, I really appreciate you stopping by, and if you need any help, support or guidance, by all means you can email audio amplifier servicing at aol.com, and I'll be more than happy to come back to you and provide any help, support or guidance that you may require. So until the next time, I wish you all the very best. Cheers and bye bye.